All right, tomorrow's test, guys. You are going to be provided with the law of sines, law of cosines, and the formulas area of triangle as well. You will be given a unit circle, so you guys can answer the question where that's needed. I'll show you that in a second. But you have to be able to solve word problems, guys. So we're talking about triangles. So if there's a word problem and it's talking about triangles, what do you think you should draw? A triangle, and then figure out what goes where. All right, if it's a law of sines problem, you need a, God bless you, an angle and its corresponding side. If it's a law of cosines, you use one of those formulas, find the biggest angle first. But any examples from the notes that we've done, WebAssign problems, if you have questions on anything from WebAssign, go ahead and ask me today as we go through this. But there's going to be 12 questions from the test. 3 of them are going to be from 6162. Now, the vector stuff, guys, the math behind the vector stuff is very easy. The top thing, the directions on your test are going to say, show all work for credit. If you just do stuff in your head and don't show me your work, you're not getting full credit. Understand that. You just tell me that the component form is whatever and there's no work behind it, you're not getting full credit because you have to show me. So let's think about some things, right? If you're given 2 points, an initial point, initial means where it starts, terminal means where it ends or stops. So if I want the component form, in order to find the component form of a vector, it's the terminal point minus the initial. The order matters because it's subtraction. So in this case, my terminal point is negative 610. So negative 610 minus 7, negative 4. This is how you would show me your work, right? You're understanding that it's the terminal minus the initial. You're showing me which represents which. Now your vector form, remember your component form has to have the V's at the end. And it's first with first. So what is negative 6 minus 7? Negative 13, okay? What is 10 minus negative 4? Positive 14. There is your vector. Guys, I can't give a lot of partial credit when you have 13, negative 14. Because that means you mixed up the points. Especially if you have a calculator, there's not going to be a lot of partial credit on this test. You have to have your signs right. Negative 13, comma 14 is very different than 13, comma negative 14. Now, if you find the vector, you're in component form, you find the magnitude. You take V1 and square it plus V2 and square it. So you have 169 plus 196. What does that give you? 365, all right. It's going to ask you for the exact answer. That means, can it break down? Not what is the decimal equivalent. Exact means if it breaks down into another perfect square and a non-perfect square, then you have a radical. But it's no decimals. Does everybody understand that? What do you need to do to prove that vectors are equivalent? There's 2 things. The magnitude has to be the same. And what else? Magnitude is your distance or length. The slope. What is that called? I agree, it's the slope. What's that called? Begins with a D. Direction. Good. In order for vectors to be equivalent, the direction has to be the same. It's got to be going in the same direction, same slope. Not just in the same direction, but it has to be the same rise over run. And the distance or length, the magnitude has to be the same in order for vectors to be equivalent. All right, now, when we did this A period, a lot of people were asking, how do you know if you're going to get one answer or if you're going to get a vector answer? You only get one answer, guys, if all you're asked to do is the dot product. In this first question, they're asking you to do what with U and V? Add them. So this is what I need to see. I need to see, okay, vector U is 2, negative 5, plus vector V is negative 3, 5. And when you add, it's first with first. What is 2 plus negative 3? Negative 1. Good. What is negative 5 plus 5? 0. There's your answer. That is perfect for the way that you showed work. If all you did was just tell me -1, 0, and I don't see any thought process or anything behind it, you're not going to get credit. You've got to show your thought process. Are they all going to be super simple like that? No, but some of them maybe. All right, what are we doing in number 4? You're distributing 2 and 5, and then doing what? Subtracting. So you have 2 times vector u. What was u? 2 -5, thank you. Minus 5, and then it's -3, 5, or 5 -3, 5? Okay. All right, we need to distribute first. So I have 4, comma, -10. Now, I'm going to distribute that -5. Some of you want to distribute 5, leave the minus sign in the middle. That's fine. I'm going to change this to a plus and distribute that -5. So I get 15 and -25. If you left it as distributing the 5 and then kept the minus sign in the middle, you'll get the same answer. But when you're adding, first goes with first. So what is 4 plus 15? 19. What is -10 minus 25? -35. And there is your answer. If you were then asked to find the magnitude, you would square 19, square -35, add them together, take the square root. But once you're in vector form, it's easy to find the magnitude. Now, on your test, it was hard for me to do this on the way I was typing this, but on your test, it'll be very apparent. Might even say find the dot product, but if you were to be, you're not going to be because we don't do this, but if you wanted to multiply these two vectors, that's how it would be written. All right, this means dot product. So what does that mean for my answer if it's a dot product? Just one singular answer. It's a value. So I have vector u, which is 2, -5. Dot product v is -3, 5. How do you find the dot product? First times first. 2 times -3 plus second times second. -5 times 5. What is 2 times -3? -6 plus -25 gives you -31. That is finding the dot product. Dot product is one singular value. You're not adding those vectors. You're not multiplying them by 2 and then subtracting or anything like that. You are just simply finding the dot product. Questions? Yeah.
Could you show how we would solve it if it was multiplying them and not the dot product?
You're not going to. You might have scalar multiplication where you're multiplying a number into a vector, but you're never going to multiply 2 vectors together. Like in this one. This is the dot product, but what do I have to do first? I have to distribute. I have 7, and I'm going to multiply that into u. I forget what u is. 2 -5. And then I have 3, and is it -3, 5? Okay, so distribute first. 14, comma, -35, right? Distribute. -9, 15. Finding the dot product, it's first times first. Know how look how I'm showing you the work, guys, that I expect to see. Plus -35 times 15. Now, this is where your calculator comes in handy. Just makes things a little quicker. 14 times -9. I got -126 plus what's -35 times 15? -525. When I combine those two, I get -651. I almost put degrees on that. Last period we talked about converting radians to degrees. Oh. All right, if you had a question like this, like let's just do another example. What if we had... What is that question saying? What is this right here asking you to find? The dot product. What do we know the dot product is? A singular value. What did you do here with this singular value that was outside of your vector? You distribute it, right? When the problem is set up like this, that does not say u times v. That says what is the dot product of uv. So you find that singular value, then you would multiply it into the u vector. So in this case, what was our dot product of uv? Negative 31. So you would take negative 31 and then multiply it into the u vector, 2, negative 5. All right, tomorrow, I will not entertain any questions of, is this what you meant? You guys have to understand the difference there. When I multiply, when I distribute negative 31 in here, I get negative what? 62. What? Negative 62 and then 155. Okay. But notice, if this is the dot product, and that's a singular value, then it's telling you to distribute that into that vector. It's not saying multiply u times v. That's dot product. Everybody got that? Moving along. Don't be confused if this is written as 6i minus 2j, or this is 4i plus 8j. Remember, I goes first, j is second. The coefficient of I is the first part of the vector. The coefficient of j is the second part of the vector. What if there is no coefficient? What's assumed to be there? A 1. What if there's no letter at all? A 0, okay? So for this kind of a question, we're not giving you guys the formula, but this is not anything you guys can't handle. What is the formula? What is on top? What's in my numerator? Dot product. And what's in the denominator? The magnitudes. That's it. You guys know it. So the dot product, show me, it's 6 times 4 plus negative 2 times 8, right? Divided by the magnitude of each. So 6 squared plus negative 2 squared. And then over here, it's 4 squared plus 8 squared. Now, some of you want to get fancy pants and try and do all that in your calculator. I think that is a horrific idea. Simplify as much as you can. Make your life a little easier. What is 6 times 4? 24. What's negative 2 and 8? Negative 16. Okay, what's 24 minus 16? 8. All right, that's a lot easier for you to punch into your calculator. Simplify your radicals. You don't have to fully simplify it. Just make it a little smaller. This is 36 plus 4, right? So square root of 40. Does that break down? Yes, but you don't need to. Don't worry about it. This becomes 16 and 64, which is what? Okay, so square root of 80. Again, does that break down? Yeah, but you don't need to because this is easier to plug in your calculator. Some of you need to, so it depends on the calculator, make sure that denominator is in parentheses. Make sure it's the square root of 40 times the square root of 80. It's not the square root of 40 times 80. Those are two separate things. But don't do the cosine of it yet. Just get your decimal value. What is 8? Everybody practice this. 8 divided by, you have the square root of 40, right? Times the square root of 80. I got all kinds of crazy answers earlier today. I got 0.14142, whatever, right? Now, it'll tell you what to round to. This is not the place you round. If it says round to the nearest tenth, don't leave that as 0.1. Your answer is going to be really far from the correct answer. At the end, it might say round to the nearest degree. That's at the end. That's when we do our rounding. But is that the angle measure? Is that theta? No. What's your angle measure? Second cosine, second answer. Your angle measure is 81.87 degrees. If you were asked to round that to the nearest degree, it would be what? About 82 degrees. Now, is it possible to do all this, enter it into your calculator, and get an error message? Yes, that just means the angle doesn't exist. I am not going to give you one of those tomorrow. I want this angle to exist so you guys know that you did it right in your calculator. But it is possible that the information that they give you, the angle doesn't exist. That's just not going to happen to you tomorrow. So if it does, go back and check, all right? All right, same thing here. This is the exact same problem, same formula. Cosine theta is the dot product. Well, my dot product is -2, -7, plus 8 times 1 over the magnitude. So I have negative 2 squared plus 8 squared and negative 7 squared plus 1 squared. So simplify a little bit. Negative 7, negative 2 is 14 plus 8 gives me 22. And then when I simplify here, I have 4 and 64. So I get what? Square root 68. And here I have 49 and 1, so square root 50. Again, if you want to break those down more, you're welcome to, but you're just throwing all this in your calculator. So we're going to end up here with cosine theta equals, practice putting this in your calculator, guys, 22 divided by parentheses, second square root, 68, times second square root, 50. Don't put both the radical, don't put both numbers underneath the radical. What'd you all get? 7,72968. All right. Second cosine, second answer, and you get 67.83. Rounded to the nearest degree, what is theta? About 68 degrees. Good. Yeah.
Can we use graphing calculator?
I'm just going to clear it out before you start. All right, there was 2 people out of my 3 pre-calc classes that figured this problem out before coming to me and saying, I don't know how to do this. So kudos to you. Now, if you didn't, no big deal. I'm going to show you. I showed you a little bit yesterday, but I'm going to show you again. This is the same exact question, just asking for a different value. All right? My formula is, cosine theta equals the dot product over magnitudes, right? You guys agree? So in this case, what did they give me? They gave me this magnitude here. They gave me this magnitude here, right? Okay, so I'm going to fill in what they gave me. They gave me one magnitude was 8 times the other magnitude is 15. What else did they give me? They gave me the angle. Guys, if you put this in right here, if you said the cosine of 2 pi over 3, all right? If you were in Miss Boyd's class, you would already know what this is because they have to memorize the unit circle. If you guys put that into your calculator, cosine of 2 pi over 3, you would get the correct answer. I'm going to give you the unit circle. What is the cosine of 2 pi over 3? Negative 1/2. How do you know it's negative 1/2? Cosine is the x value. I'm going to give you an angle that's on the unit circle. So what I have given you here is the actual cosine of the x. It's negative 1/2, you said? All right. So what are we trying to find? We're trying to find the dot product. Well, guys, this is what can be confusing. This right here is one singular value, isn't it? It's not u times v. That notation of u dot v means what is the dot product? That is one singular value. Don't use u and v there. Use any letter you want. I'm going to put an x. You're finding a singular value. So if you cross multiply here, what's 8 times 15? So I have negative 2x equals negative 120, right? Divide both sides by 2. What does x equal? Negative 60. That's the dot product, guys. A lot of people, after we set it up, they got confused with like, how do you find the u and the v? Remember, that's a notation. That means dot product. That is a singular value. So that's all that you're looking for right there. It's going to say in the directions exact value. Lots of you were having problems with this on WebAssign. What does it mean to be exact? Do you round? Yes or no? Can you have an exact answer that's rounded? No. Is this an exact answer? Yeah. Let's find the exact answer here, okay? Let's think about what we have. We have the 7. We have the 22 on the bottom. We have the cosine of 5 pi over 6 because it's over here on the unit circle. What is the x value of 5 pi over 6? Negative root 3 over 2, okay? negative square root of 3 over 2. And we're trying to find the dot product, correct? We're trying to find this value up here. Guys, an exact value has, can you get an exact value? Can you multiply 7 times 22, that's negative 154, and then times it by the square root of 3 and get an exact number? No, this is just negative 154 times the square root of 3. We've done that a million times, guys. And then I have 2 times x. How do you get the exact value here? We did this with right triangles, 30, 60, 90s, and 45, 45, 90s, which are all based upon the unit circle. Divide both sides by 2. What am I actually dividing by 2? The square root of 3 or the 154? So the 154. Divide that by 2, and I get negative 77 square root of 3. That is an exact value because the square root of 3 is an irrational number. If you give me the decimal equivalent, that is not correct. You have to have the radical. If it does not come out to be a pretty whole number, like negative 60, then you have to keep the radical. You might have a square root of 2 in it because it's on the unit circle. You might have a square root of 3. That's okay. Questions? All right, let's get on. We're almost done. I'm going to do one from WebAssign because some people had some questions about that. How do you prove, yes ma'am. Yeah, hang on. How do you prove that vectors are parallel? Okay, same slope. I understand what you mean by that, right? The direction. But there's another thing, and I don't want to say another thing, but these aren't lines, right? We're not dealing with lines. So we can't just find the slope because if I have these two vectors, I don't have 2 x's and 2 y's, right? I have combinations of those things. How do we prove that vectors are parallel? You take the first part of vector 1 and put it over the first part of vector 2. Then you take the second part of vector 1 over the second part of vector 2. If those things are the same, then they are parallel. Similar, very similar, Jeremy, to same slope. I know what you mean by that. How do you prove if they're orthogonal? First of all, what does orthogonal mean again? It means they meet at a 90 degrees, so it's perpendicular. But we're not going to use the word perpendicular. We're using orthogonal. How do you prove that that vectors are orthogonal? The dot product equals what? Somebody asked last period. Well, if you just prove that they're opposite reciprocals, does that make them orthogonal? I understand the concept behind that because they're very similar to lines. But to properly mathematically prove that vectors are orthogonal, you have to use the dot product. So that's what I need to see. If both of those things don't happen, your answer is neither. Now, guys, this is a really simple question, but it's also a very simple question that you guys could make silly mistakes on. All right, so just take your time. All of you in here are smart. You all have a calculator. Just take your time. If I think that these could possibly be parallel, right? This is like those odd, even, neither ones. You can't just tell me, yeah, parallel. I have to see why. So show me. You take the first part of vector 1 and put it over the first part of vector 2. Does that equal the second part of vector 1 over the second part of vector 2? No. If you need to simplify, 6 over 5, is that the same as positive 5 over 6? No. So let's try the dot product. Let's see if these are orthogonal. So I have 6 times 5 plus negative 5 times negative 6. Somebody last period is like, oh yeah, they are. I can see it. Guys, what's 6 times 5? 30. Plus, what's negative 5 times negative 6? 30. What's 30 plus 30? 60. What does the dot product have to be for them to be orthogonal? 0. So does this one work either? So what are these two vectors? Neither. Again, not much partial credit's going to be given. If you are just being hasty and making silly mistakes, I cannot give you credit for that. So just take your time. All right, same exact thing. We're going to do it again. Take the first part of each, second part of each. So negative 4 over 8. Does that equal 7 over negative 14? Well, simplify. What's negative 4 divided by negative 8? Negative 1/2, right? What's 7 divided by negative 14? Negative 1/2. What did you guys just prove to me? That they're parallel. Takes 2 seconds, but do not tell me, well, I could just see it. Show me. A proof starts with a statement and ends with something equals something. Show me that the left side equals the right side. All right, last one. Let's look at parallel. Is this parallel? All right, first part over first part. Does that equal second part over second part? What's 3 over 6? Simplify 2. 1. What is it? Half. And what is this? Negative 2/9. Are those the same thing? No. Okay. Dot product. Are these orthogonal? 3 times 6 plus negative 2 times 9. 3 times 6 is 18 plus negative 18 equals, what did you prove? That they're orthogonal. Orthogonal. That's the word we use. We're not using perpendicular. Can you guys pull up for me your web assignment, please? I just want to grab a question. All right. Say you had a question that says, for what value of k, right? Makes the vectors parallel or orthogonal or whatever. It's a basic equation, guys. Hang on one second. Negative 3ki
plus 5j.
Okay.
And then b equals 2i minus 4j.
All right, so first thing I would do is I would write it in vector form. So I would say negative 3k and then positive 5, right? And then here I would have 2, negative 4. Agreed? Now, if in order for two vectors to be orthogonal, their dot product has to be what? Dot product has to be what? Equals 0. So set up the equation. Negative 3k times 2, right? Plus 5 times negative 4 should equal what number? 0. You are solving a basic equation. Negative 3 times 2, this gives me negative 6k minus 20 equals 0. Now what do I do? How would I solve this? Add 20 to both sides. So negative 6k equals 20. Divide by negative 6. So k equals, don't give me a decimal. What does k equal? Negative 20 over 6, which reduces to negative 10 over 5. Okay. Why did I say 3? I'm sorry. Negative 10 over 3. All right. Now, how do you know if that's right or not? Put it back in right here. If I said negative 3 times negative 10 over 3, what happens here? Yeah, the negatives cancel, right? And the 3's cancel. So if I had vector 10, 5, and I had vector 2, comma, negative 4, right? That's what would happen if I put that number right there. You guys agree with me? Okay, so find the dot product. What's 10 times 2 plus 5 times negative 4? What's 20 minus 20? 0? Then there, you can check it and see that you're right. But in order for vectors to be orthogonal, their dot product has to equal 0. So you're just setting up a very basic equation. First times first plus second times second. If you were given a problem and it said u was 7i plus 6j and v was 13j. All right, guys, what is vector u? 7, comma 6. Agreed? What is vector v? 0, comma 13. Somebody's like, how did you know to put the 0 first? Because I in the alphabet comes before j. I is always first. If there was no number in front of I, it was just an I, what do you assume is there? A 1. Okay, good. All right, does anybody have any other questions? No? We're okay?